Okay, this is going to be question number 2 from the 2023 Calc AB exam, and it's kind of a working with velocity problem. So Steven swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Steven's velocity is modeled by v of t equals 2.38 e to the negative 0.02 t sine of pi over 56 t. So if you don't have a calculator that does pretty print, that's going to be pretty tough to enter in, but be careful with it. Where t is measured in seconds and v of t is measured in meters per second. All right, for part A, we want to find all times t in the interval from 0 to 90 at which Steven changes direction. We need to give a reason for our answer. So what I've done first is I just defined on my calculator v of t. Then what I did was I went to a graph page. I graphed v of x because on the graph page you have to use x as your variable. I also graphed 0, and then I did menu 814 to find the intersection points. You can see the only intersection point where we're going from positive to negative or negative to positive or having a sign change is at 56, which means that's the only time that he changes direction. So I'm going to say Steven changes direction at t equals 56. My reason is going to be because v of t changes sign there. They don't really care if you're going positive, negative, or negative, positive, just a sign change. That's part A. Let's take a look at part B. Find Steven's acceleration at t equals 60 seconds. Show the setup for your calculations and indicate units of measure. And then we'll have to say if Steven is speeding up or slowing down at 60 and give a reason for that. So it's really like they're asking multiple questions in each part these days. But let's do this. So first up, we have to say that the acceleration is the derivative of velocity. So we're saying a of 60 is v prime of 60. That's going to be approximately. We use the calculator. So I found the derivative at 60. I got negative 0.036. So approximately negative 0.036. We need units, right? So it's the derivative of velocity. I need to know the units of velocity and the units of t because it's v of t. So t is measured in seconds and v is measured in meters per second. So this will be the units of velocity, which are meters per second, and then per the units of time, which are seconds. So meters per second per second. I don't like to write meters per second squared, but that is totally acceptable. Now we need to talk about speeding up or slowing down. To do that, I need to know the sign of velocity, and I don't think I've actually found that yet. So I just on my calculator found v of 60. It's negative, so I'm going to say since v of 60 is approximately negative 0.160, or you could just say is less than 0, which is actually kind of safer because what if we rounded that incorrectly or anything like that? So if v of 60 is less than 0, I'm going to say speed is increasing, and then I'm going to give my reason. This might actually do it. I don't always know how the graders are going to interpret it. Like I've shown that acceleration is negative, I've shown that velocity is negative, and then I said speed is increasing. But I'm going to say because velocity and acceleration have the same sign, because that is definitely the reason. All right, let's take a look at part C. Find the distance between Steven's position at time 20 and his position at time 80. Show the setup for your calculation. So I think I maybe overthought this. We're looking for the distance between them, not the distance traveled. We're basically kind of looking for displacement, but we want the absolute value of displacement. So I read this and I thought this has got to be the absolute value of displacement. I think it would be fair to have to consider that. So that would be the absolute value of the integral from 20 to 80 of v of t dt, right? The displacement is the integral from 20 to 80 of v of t dt. That could be positive. It could also be negative, and we want the distance between them, so we'd have to take the absolute value if it is negative. But when I went to the calculator, it's not negative. So I don't actually need the absolute values. I don't think you would need that in your work, but I do think conceptually going forward, you should look out for that idea. So I would say approximately 23.384, and then our units are going to be meters, although it does not ask for that. So I'm putting it, I don't think there's a point associated with meters. All right, let's take a look at part D. Find the total distance Steven swims over the time interval from 0 to 90 seconds, and show the setup for your calculation. So this, in contrast to the previous one, is going to be the integral of the absolute value of velocity. That's distance traveled. So I'm going to show my setup is the integral from 0 to 90, absolute value of v of t dt. Approximately, this is a calculator question, so we just punch it in, and then we'll say 62.164, and then meters are the units that he's traveling in. So that's the entirety of question number 2. I think this, again, is a pretty fair question. I hope this was helpful, and good luck.